talking about transformations, we did transformations for absolute value functions. We did transformations for quadratic functions. And now we're doing them for our square root functions. But if you remember, the same rules applied the two previous times are going to apply here as well. So we said we had, let's do it for a quadratic. If I have a negative in front, what did that do to the picture of my graph? Right. So this is going to make it flip or reflect. Okay. And then there was always some value A that could be out in front, right? And depending on what that number was, it either made it stretch or it made it shrink. So if this number was greater than 1, then we had a stretch. And if this number fell between 0 and 1, then we had a shrink. So between 0 and 1 was things like 0.75 or 1/2, right? It had to be less than 1 for that to happen. Okay? And then we had a parentheses with x plus or minus some number in there. Do you guys remember what that number inside the parentheses made happen? Left or right? Good. So this was left and right. And it was always opposite of what it said, right? If it's in the parentheses, it's opposite of what it says. So if it says x minus 2, in my head I would think, oh, negative, that means I'm moving to the left. But we know if you take it out of the parentheses, set it equals 0, it actually becomes the opposite number. So minus meant to the right, plus meant to the left. And then also there could be some value out here on the end, plus or minus. And anybody remember what that made happen? Up and down. So this one was exactly what it said. If it said plus some number, it moved it up. If it said minus some number, then it moved it down. Okay. All right. It says, graph each function, state the start point, the domain, and the range for each in both set notation and interval notation. So the first thing that they give us is y equals the square root of x. So remember, we call the one with the least amount of changes possible made to it the parent function. So for the quadratic, it was just y equals x squared. For the absolute value, it was just y equals the absolute value of x. So it had the bars on the outside. This is going to be our parent function for square root. Y equals square root of x. So this is the parent function for square roots. Okay? And we will graph it in our calculator too, but I also want you to realize we can come up with our own points if we wanted to graph this and we did not have a calculator available to us. So what I could do is just pick some numbers for x, plug them in, and my output is the y, right? Now, we can obviously see whatever we plug in there, we have to take the square root of, so we're going to pick some numbers that actually have a square root, so it makes it easy on us. Okay. So we could start with 0. What's the square root of 0? Very good. 1. What's the square root of 1? It's 1, right? There is no square root of 2, so we probably don't want to use that one. There's not a square root of 3, so we don't want to use that one. So maybe 4. What's the square root of 4? 2. And that gives us enough points to plot on a graph so that we would know what the picture would look like. So I'm going to come down here on this little graph and plot those 3 points. So we got 0, 0, 1, 1, and 4, 2. So it looks something like this. Okay. You also are welcome to go into y equals, there's something in there when you clear it out, and you can graph it in here as well. To put a square root in your calculator, remember you press second x squared, and it's just the square root of x, so we graph it, and we can see it does look like what we graphed here. It just goes off to one side. The reason that it doesn't make that same shape as a parabola is because can I take a square root of a negative number? No. So I can't put any negative numbers in there because our calculator knows that those don't actually exist. We call those imaginary. So the other part where we would plug in negatives just doesn't exist. Okay. All right. So the start point of this is at 0, 0, right? So that's what I'm going to put up here where it asks for the start point. Okay. Then it asks for the domain. Okay, so domain is my x values, right? That's left and right. So we can see that this thing does not go left forever. It starts here, and then it goes right forever. Doesn't end. So I would need to say that it starts at 0 and then goes to the right forever. As I move to the right, the x values get bigger or smaller? Bigger. So I'm going to put that x is greater than or equal to 0, because as it moves that way, things get greater or bigger. Okay? And they did ask for set and interval notation. So it starts at 0, right? And it goes off forever, which we would say to infinity, right? And then we have specific things we put on the outside of those to show whether it's included or not. If it's not included, we use a normal parenthesis. If that number is included, you use a bracket. Okay. So 0, that is a filled in point, so it is included. So on this side, I will use a bracket. Okay. But for infinity, since that never actually ends, I can't put a stop on it, right? So I have to leave it as in regular parentheses. Or if that point at 0 was an open circle, then I would use a parenthesis. It's not included. All right, then they want us to do the same thing for the range. So does this thing go down forever? But is it ever going to stop going up? Okay. So I want to say that it starts here, which is at 0, and goes up forever. So how could I write that? Y is, right, as I go up, things get bigger. And it also is going to start at 0 and go off to positive infinity. Okay. All right, this next one here wants us to describe the transformations we see. So we're just going to work our way through the equation. The first thing that I notice is this negative in front. And what did we say negatives in front make happen? Right, flipped or reflected. Okay? And then we said anything that is inside with x moves things left and right. It's minus 3. Remember, it's opposite of what it says. So minus 3 means I'm going to move right 3. Very good. And then lastly, I have this plus 2 out here on the end that is not inside with x. And that moves things up and down. So I would put that it also moved up 2. Okay. So since we know that this is what the original looks like and it starts at 0, 0, I'm just going to make all the changes we just talked about to that specific point. So instead of being at 0, 0, we said that we needed to move right 3 and up 2. So now my starting point is here. Okay? And then we're just going to move the other points in relation to that. So previously, we just went over 1 and up 1 to get to our next point, right? And this did not get stretched or shrunk, so we still should have a point there. But does the graph still face right side up? No, it flipped upside down. So instead of going over 1, up 1, I'm going to go over 1, down 1. and I kind of run out of room here to do that next point. But we know now that our graph makes this kind of a shape, and it's going to go off this direction, right? And again, you can always graph that in your calculator. We go into y equals, we've got negative square root of x minus 3, move outside of the square root, plus 2. There it is. Okay. All right, so now that we know this is what our picture looks like, our start point is where? 3, 2, good. And for my domain, those are my x values. We are still moving to the right forever, but now I start somewhere else, right? The furthest that I move to the left is now 3. That's my starting point. So instead of being greater than or equal to 0, it's going to be greater than or equal to 3. That's where it starts now. And then this part, again, pretty much the same, but instead of starting at 0, I'm going to put a 3. Okay, now the range is a little bit different because previously it was curved going up, and now it's curved to go down. So now instead of going up forever, it goes down forever. So that's going to flip the direction of my inequality, right? So now it's y is less than or equal to, and instead of starting at 0, the highest y value in this case is 2. Okay. That also changes this one a little bit because I don't go to positive infinity anymore. If I'm going down, I'm going to negative infinity. And when you do these, you always list the smallest thing first. Negative infinity would be the smallest, so I would put negative infinity all the way up to positive 2. Okay. All right, last one, Mike. Oh, just kidding. There's a couple on the back, but I won't graph you the calculator anymore. I feel like we're kind of getting the hang of it. So it says that this one goes where? Down 6. And that's the only transformation being made, right? So whenever I go to put this on the graph, it looks very similar to this one, but instead of being at 0, 0, it's now going to start at 0, negative 6, which is actually 1 point off our graph. And then I'm going to plot the rest of the points based off of this one, right? So for that first one, I should go up 1 and over 1. And then for the next one, I'm going to go over to 4, but up 2 places, right? So 1, 2. Sorry, I went up too many. All right, and then we connect it. It's going to look something along these lines, all right? And again, you can graph it in your graphing calculator also. Pull up the table if you wanted some specific points to know what to graph. All right, so where is my new start point? Very good. Okay, and for my domain, those are my x values. My domain hasn't really changed, right, from the original. It still is starting at 0 and going off to infinity. So it still is greater than or equal to 0, or from, bracket, from 0 to infinity. Okay, my range has changed some because it got moved down, right? So the start point is at negative 6, and then it goes up forever. So y is greater than or equal to negative 6. And then we have from negative 6 off to infinity. Right. Okay, number 4. What transformation do we see here? Very good. So on my graph here, instead of starting at 0, 0, I'm going to move to the left 3. That's 1, 2, there we go. All right, and we can use those couple of points we already had from the front. I know I should go over 1, up 1, and then also 1, 2, 3, 4, 2. So right there. And there's our graph. Okay, so where's my new start point? Very good. Okay, and what's our domain on this one? Greater than or equal to -3. Or that could also be written as going from -3 to infinity, right? Okay, and my range, did this move up or down at all? No, so it's still going to be the same as that original one. Y is greater than or equal to 0, or it goes from 0 to infinity. Okay, so this one has a few more transformations. What's the first thing we notice on number 5? Reflex, good. Okay, what else? Very good. And last, we also move, very good. All right, so instead of starting at 0, 0, I'm now going to move left 5 and down 1. Okay? And once I move here, I'm going to go plot my other points, but instead of going over and up, my points are going to be over and down. So something kind of like this. So where's our new start point? Very good. Okay, and then my domain, so this is going to be for x. Where does x start now? -5. And is it going to get bigger or smaller as it goes? Bigger. And if I was going to write that differently, I could put it goes from -5 to infinity. Okay. And then for my range, where does y start now? -1. And is it going up or down? Down. So y is less than or equal to -1. Or it goes from -infinity all the way up to -1. Okay. And last one, what are my transformations for number 6? Very good. Okay, and so I'm going to come down here. Instead of starting at 0, 0, I move left 4, down 2. Now this one hasn't been reflected, so I'll still go over and up for my points. So over 1, up 1, and the other point from the beginning was over 4, up 2. Something like that. So where was my new start point? Very good. And since this one's going up, it's going to have a similar domain to number 4. It just starts at -4 instead of -3, right? Okay. And again, my range will also be similar to number 4, but instead of y's lowest value being 0, its lowest value now is negative 2. So that's what I'll plug in place of 0. All right. Okay, so in this next little section here, it says on problems 7 and 8, they want us to describe the transformations made to the parent function. So we're basically just describing what we see here. Okay. So this 3/4 in front, what is that going to make happen? Shrink, very good. So shrink by 3/4. Okay. Next thing we have is that plus 12. What's that going to make happen? Good. And that plus 3 on the end. Very good. Okay. And number 8. What do we notice first on this one? Very good. And that 2, what's the 2 going to make happen? Very good. Remember, the negative doesn't determine whether it's a stretch or shrink. Okay. What about that minus 2 underneath? Very good. And lastly, very good. Okay. Then on these last 3, they give us 2 transformed functions. And they want to know, how could I get from this one to that one? What would I need to change about this one to make it become that one? So I'm looking for any differences I see between the 2. The only difference between these 2 equations is the up and down shift, right? Okay, so this one is currently at positive 3, so somewhere up here. And then this one is at negative 2. So how much would I have to move to go from positive 3 down to negative 2? I have to go shift 5 down. Right, so that's what I'm going to put right here. Shift down 5 units. Okay. On number 10, what's the difference between these 2? The left and right shift, right? And how much did you say we would need to move? 10 units to the right. Good. Okay, and then on this last one, there's 2 differences, right? So I'm going to start with the left-right shift. How much would we need to move on that one? 2 units, right? But remember, because it says plus, it's actually over here. 1, 2, 3, 4 to 2. So if I'm moving from here to here, I'm moving to the right. Okay. So shift right 2 units. Okay, and to move from negative 5 to negative 1, how would I